Introduction for real-life purpose of a traffic light. Traffic light is very crucial, especially nowadays. By having this, we can easily get across the road whether we use any vehicle or by walking. The purpose of the traffic light is to guide any vehicle when to stop, wait, and go. Traffic lights also provide safety for drivers and for the people passing by.
In Tinkercad. We use the 555 timer and the 4017 decade counter to simulate a working stoplight system. Let's break it down step by step. Let's start with the components we used: LED lights, red, yellow, and green to represent stop, slow down, and go. Resistors connected in series with each LED to prevent them from burning out. Breadboard, where we build and connect our circuit without soldering. 555 timer IC generates clock pulses that act like a heartbeat for the system. 4017 decade counter IC uses those pulses to switch between outputs one by one. Polarized capacitor and additional resistors. These work with the 555 timer to set the speed of the pulses. A 5V DC power supply to power the entire system. We also used a function generator in Tinkercad to simulate pulses manually for testing. First, the 555 timer is configured in a stable mode, meaning it sends out a continuous stream of on and off signals or pulses. This is done by connecting the capacitor and resistors to pin 2, 6, and 7 of the IC. To set the timing interval, we then connect the output of 555 timer pin 3 to the clock out input of the 4017 counter. Each time the 4017 receives a pulse, it shifts its output to the next pin, turning on a different LED. Only one LED lights up at a time, red first, then yellow, then green. Each LED is connected to a different output pin of the 4017, usually Q0, Q1, and Q2, and each output has its own current limiting resistor. Once the sequence is complete, the 4017 resets and the pattern repeats, just like an actual traffic light. We power the entire supply using a 5V DC supply. The positive rail of the breadboard is connected to the VCC pins of the both ICs. The ground rail connects to all of the GND pins and the negative side of the capacitor since it's polarized. We also connected pin 15 reset of the 4017 to ground to keep it enabled, and pin 13 enabled to ground as well. You can fine tune the LED timing by adjusting the resistor and the capacitor values. In the 555 timer circuit, this changes how fast the light cycle from red, yellow, and green. Now let's run the simulation. As soon as we start, the 555 timer sends out pulses. The 4017 receives these and switches between outputs, turning on red, and then yellow, and then green, one at a time. The LED lights up in a perfect sequence, just like a real traffic light, with consistent timing between each transition. We can increase and decrease the speed by changing the frequency of the clock signal. You'll also see the current voltage indicators active in real life time, showing the components are working correctly.
Here's a list of components that are presented in our traffic light activity. LED lights. This is the most important part needed for our project, as it helps provide visual instructions and help notify what they symbolize and what each light does. Breadboard. It is a device that allows you to build and connect electronic circuits that allows electrons to flow through the wires that you plug into. Resistor. It basically limits or regulates the flow of electrical current that goes through the circuit because of resistance.
Polarized capacitors. It acts as a storage of energy that helps power the 555 timer on the breadboard. Now, the 555 timer serves as a cool-down system for the LED lights to switch on or off during the process. Now, power supply. The power supply provides electrical energy needed for the circuit. It can also control how much voltage you use.
How the system works. This is a quick explanation about how the traffic light system works. First, this is what we use on our project to make traffic light. We use breadboard, LEDs, color red, yellow, and green, push buttons, 9V battery, 555 timer, resistor, capacitor, and wires. The LEDs represent the traffic signals. The 55 timer is the main component that controls the timing. It sends signals to turn on LEDs on and off in a specific pattern. Resistor and capacitor control how long each light stays on. The green LEDs lights up to let car go. Then yellow LED turns on warn drivers to slow down. And after that, red LEDs turns on signals vehicles car to stop. The cycle repeats automatically. Push buttons can also be used to simulate manual control, like pedestrian crossing. This helps us to understand the timing, flow, and safety in Tinkercad, even a real-world system.
Creating a basic traffic light circuit using Tinkercad was both a challenging and enriching experience. This project allowed us to explore the basic components such as 555 timer, LEDs, resistors, capacitors, and breadboard. In creating this project, we had a better understanding on how each component plays a specific role in the flow of electricity. We had to think critically about how to explain each stage, from the real-life relevance of traffic lights to how the circuit works, and demonstrate it through Tinkercad's simulation. Most importantly, we learned that electronics isn't always about coding. It's also about logic, timing, and understanding how physical components work together. It showed us the value of precision and creativity when designing circuits.